Okay, so I'm going to introduce you to 8.5 and 8.6. These are what are called inequalities, solving inequality, linear inequalities, and linear programming is what it's called. So we're going to use what's called a graphical method, and we're going to use what's called the intercept method to graph. So the problem is 4x minus 3y is greater than or equal to 12. What we're going to do is, this is your inequality, and you want to solve it by graphing. So we're going to rewrite this as equals. Okay? So now you want to graph this. So there's multiple ways of graphing it, rise over the run and many ways of looking at it. I'm going to show you how to do it using the intercept method, how to use the x and y intercepts. So we're going to let x equal 0 and we're going to solve for y. We're going to let y be 0 and we're going to solve for x. So if x is 0, really just negative 3y equals to 12. Divide both sides by negative 3, y is negative 4. So that's what's called the y-intercept. When y equals 0, you solve for x. So x is 3. Again, the x disappears, so 4x equals 12, x is 3. So you have your intercept. So go to the point 3, 0, which is here. Go to the point 0, negative 4, and connect the dots. Make a line. Now, because it's equals, this is a bold line. If it was not equals, it would be a dotted line, because we wouldn't include the line as the answer. But because you can equal this, it means the line is part of the answer. Now, the idea is to decide where to shade. So what we do is we pick a point that's not on this line. I like to pick 0, 0 for simplicity because 0, 0 clearly is not on this line. So when you choose 0 for x and 0 for y, the left side is 0. 0 is not greater than 12, which is what all of this says. Because 0 is not greater than 12, all of this stuff to the left side of this line or to the other side of this line here, all of this will fail, which means the other side of the line will be the answer. So you shade the other side. Had this been true, we would shade everything to the left. But because it's false, we shade the other side. And so this graph is the answer to that problem. That's your solution. That's all it is. So as it were here, let's say 3x, and the reason I scribbled it out here for number 3 is because I changed it from an equals to a strictly less than. I wanted to give you one where it's dotted. So 3x plus 2y is greater than or equal to 6. Look at when it's equal. Let x be 0, 2y equals to 6, and so y is 3. Let y be 0, 3x equals 6, so x is 2. So you go to the point 0, 2 and the point 3, 0. Those are what are called your intercepts. X-intercept, y-intercept. Pick any point you want to either side of this line, doesn't matter. I pick 0, 0 for simplicity. If you could figure it out here, if you put a 0 for x and y, that's not bigger than 6. So down here, anything under this line will fail. So that means everything above will succeed, will be true. So you shade over it. That's all this is. X plus 2y less than 6. You can see my work here. It said equal to 6 instead of less than. Plug in values. 0, I get 3 for y. Plug in 0 for y, I get 6 for x. So I connect the dots here. But now the problem is this, because this is strictly less than. This is where it's equal. So it's equal is not part of the answer, so we have to put a dotted line to show that that's not actually part of the answer. So if it's not equals, it's a dotted line. If it's equals, it's a bold line. That's how that works. Now, if we pick a 0 here and a 0 here, 0 is clearly less than 6. So 0, 0 is down here, so the bottom of the line is shaded. And that's how this works. And that's how you graph, that's how you shade, graph inequality. So this part of it is really the 8.5 part, kind of showing you essentially how to work with inequality. And also the idea of 8.5 in here is the idea of solving things with more than one. So 8.5 is what we've done so far, and a little bit of this. So now, I'm sorry for the mess there. I'm just trying to point out things, arrows, and kind of use a pen here. But nonetheless, solving a system, meaning if you have more than one inequality, maybe things intersect. So you take one inequality and you graph it like you normally would. You take the other inequality, or sorry, take one inequality, graph it how you would, and then get the other inequality and graph it like we did. So here I said equal to, plug in 0 for x, solve for y, y is 3. And you can show that work if you'd like to. When y is 0, 3x equals to 15, so x equals to 5. Over here, when x equals 0, negative 3, y equals 9, so y equals negative 3. When y is 0, x equals 9. So let's see. This line right here is this point. This is actually That's 9 right there. Sorry for the mess. But that's the 0.9. Maybe I do like this. 9. Add to the mess, huh? So that's 9, and that's -3. So I connect the dots. Now notice it's bold line because they're allowing for equals. And this one, 0, 3, and 5, 0. And the idea is kind of where to shade things. So if I pick 0, 0, and look at this line, if I put 0, 0, notice that that will be true. So for this line, I would shade everything under this line. Okay, but I didn't physically show the shading here because you want to see where these two shadings intersect. So the first shading is here, so I put arrows to show that's the direction the shading would go. Now the second one, if I pick 0, 0 for this one, you see 0 is not going to be greater than 9. So I don't shade above, I actually just shade below. So I shade here and I shade here. Where the two shadings would overlap is this part. So this is the answer, this is the shaded part. This is the answer to this problem. And that's how it goes. Again, we shade where both inequalities have the same shaded regions. In other words, where do both shadings intersect? And that would be in here. That's all it is. And now here, this has multiple ones, it has 4 of them. So x plus y equals to 4. Again, plugging in 0 for x, solving for y, plugging in 0 for y, solving for x. I get this one right here, this line. And again, they're all bold. Now, if any of them didn't have equals, then some of those would be dotted lines. But they're all equals here in the way I'm setting it up. Now, 2x plus y is equal to 5. X is 0, y is 5. Now, if y is 0, x is 2.5 or 2.5. So that would be this line when I connect the dots. When x equals 0, that is the y-axis actually. That's x equals 0. When y equals 0, that's a horizontal line of that. In other words, that's the x-axis. So these two are pretty easy to find. You don't have to plug in anything here because x greater than 0. Now, x's are like this. So if this is x equals 0, x greater than 0, we shade everything to the right of the y-axis. So that's what these arrows mean. If y equals 0 and y is vertical, this will be greater than 0, will be above. So it shades above the x-axis, which means so far between these two bottom ones, it means shade the first quadrant. So far. Then I plug in 0 for this one. 0 here would be less than 4, less than or equal to 4, which is true. So for this line right here, I would shade everything under it. So that kind of puts me at this little region so far. Then I get the other line, and I say when x is equal to x and y are zeros, that's also true, less than 5. So I'm shading everywhere under these two lines to the right of the y-axis to the above the x-axis. So that leaves this little region down here. So keeping in mind, what we want to do is we want to look at the points of intersection. So for this one, we want to figure out where do they intersect. So this is the point 0.04. That's easy. This is the point 0.00. This is the point 2.50. We got that. To figure out this point where they intersect, we have to solve the system with these two equations. So here we distribute. Again, I'll try to cancel the x's first. So I'll distribute the -2 like we did in algebra, or like you did in algebra. We cancel x. So -y equals to -3. So y equals to 3. So if I plug in a positive 3 into one of these two equations, I get x equal 1. So that's the 0.13. That's just typically what you want to do is you want to figure out where do they intersect, especially when you have to graph something like this on software. You want to see essentially where they intersect. That shouldn't be so bad. Okay. Just in case, you don't have to do this, but if you have, I may here, you have a graphing calculator, y equals, you'd have to solve this equation for essentially x, or for y. So if I subtract both sides by x, I would get 4 minus x. Now this one, if I solve it for y, I get 5 minus 2x. So then I would essentially go to the graph, and you can kind of see how they would look. So those lines are these lines that I drew here. Now, sometimes you want to say, well, I don't want to, this is kind of a lot of work here to solve for x and cancel. I get that. So up here it says calc. I'm going to go second, calculate. And I'm going to go where it says intersection. So it says first curve, which is this line. Hit enter. And the second curve, which is this line. Hit enter. And then it's kind of guessing. So you press enter again. See that? 1, 3. Saves you some time. You guys want to point that out there. But that's how you see that. I did the work here. I'm so used to doing all the work by hand. But just so we're clear on that. Okay. So 8.6 talks about linear programming, which is what's called an objective function. So what the next section is part of all this together, but what the next section is going to have is this. It's going to have an equation up here. It's going to say z equals something with x and y. So we're going to have to do all of this, but we're going to have to do all of this. But we have to look at all the points of intersection. So you see these 4 dots? We're going to take these 4 dots, and we're going to plug it into what's called an objective function. The biggest answer is the maximum, the smallest answer is the minimum. That's the only difference. I'm going to do a couple of those. I'll walk you through it, and then kind of see how that goes. I'm only going to do 2 because this is the same idea. So an objective function is a function they're going to give you. Typically, they call this z. Like z equals this value. This is just random, 3x plus 5y. So they give you a function to shoot for. So the inequalities, you do all of this work. So 2x plus y, what we just did a while ago. 2x plus y equals 8. Plug in x to be 0, y is 8. Plug in y to be 0, x is 4. This is y equals 2 and x equals 1. So these are vertical lines. So x equals 1 is here, vertical. And we want greater, so we want to shade everything to the right of that line, x equals 1. We want to shade everything to the top of y equals to 2. Okay? Then this line coming across is here. So when I plug 0, in fact, when I plug a 0 in here for x and y, I get true. So that means I'm going to shade everything to the bottom of this diagonal line. If I want greater than x greater than 1 and y greater than 2, it means what? It means everything above this horizontal line and everything to the right of that vertical line. So that gives you a triangle. This point here is where this y equals 2 intersects with x equals 1. Well, that x is 1 and y is 2. That's what it's telling you. So that's the point 1, 2. This point is when y equals 2 intersects the line 2x plus y equals to 8. Well, if y equals to 2, just plug in a 2 for y and solve for x. So x equals 3. So that's the point 3, 2. Now, where this line intersects this vertical line is where 2x plus y equals 8 intersects x equals to 1. So plug in a 1 in for x. Solve for y. Y is 6. So those 3 points, at the point 1, 6, at the point 3, 2, at the point 1, 2. I'm going to go. Now, this is normally where a little while ago we finished here. But now we're going to plug in these values in for x and y. So plug in x to be 1, plug in y to be 6. Plug in x to be 3, plug in y to be 2 into this objective function. And then plug in x to be 1, y to be 2. When you do that, you get 3 different answers. The biggest answer is what we call the maximum. The smallest answer we call the minimum. Linear, it's called linear program. It sounds weird to say linear programming, but it's linear because of lines. Programming is because you're trying to program the best possible scenario so that you can get the best out of your business or the best bang for your buck or pay the minimum or make the most profit, essentially. And then finally here, there's 4 lines that I kind of cut all the way through. So 4x plus y greater than or equal to 8, x plus y greater than or equal to 5, 2x plus 7y greater than or equal to 20, and then 4x plus 5y less than or equal to 40. So again, I did all 4 here. I did the points where I let x be 0, got y, let y be 0, get x. I did all of them here. One of them comes out to a fraction. This is for this one, when x is 0, y is 20 over 7. Now I leave it as 20 over 7 because I don't know if the computer, the software is going to want a fraction or it's going to want the decimal. So this is about 2 and change. So the first line here, 0, 8, and 2, 0, would be, let's see, this line. So 4x plus y is equal to 8. That's this one. Then x plus y equal to 5. That's this line. Then 2x plus 7y is greater than or equal to 20. That is this line. Sorry, that is, where am I here? That is this line, sorry. This line coming across. And then ultimately, 4x plus 5y less than or equal to 40 is this line. So the intersection points, this one is where both of these lines intersect, and they both have the same y-intercept, so that's easy. This one has the same x-intercept at 10. So this point is where this line, 2x plus 7y equals to 20, and the line x plus y equals to 5. I solved it off to the side, but I got the 0.32, and then that's where this line intersect this line, x plus y equals 5, 4x plus y equals 8. They intersect the 0.14. You could use the calculator like I showed you, just do 2 lines at a time so you can kind of see all the intersection points. So when you plug in 0, 0 for all of them, what will happen is 3 of them are greater, 1 of them is less. So I'm going to shade to the right. See this line here, this line here, and this line here. I'm going to shade all of it in the upward direction. Except the one on top, I'm going to shade in the inward direction. So it makes all this little polygon here, makes a little trapezoid, or not necessarily a trapezoid. Yeah, it kind of makes a trapezoid. Well, we call it a quadrilateral. So there's 4 points: 0, 8, 1, 4, 3, 2, 10, 0. So take all these 4 points, and your objective function is 10x plus 20y. So plug in 0 for x, 8 for y, 1 for x, 4 for y, 3 for x, 2 for y, 10 for x, 0 for y in here. Get 4 answers. The big maximum is 160. The fact is that there's 2 minimums here. They both have 90. So you can have a problem that has 2 minimums and or 2 maximums. If you have anything more than 2 minimums or maximum, then you don't really have a min or max. So really at most you have like 1 or 2. At really just 1 max is what you're looking for, 1 minimum. But in some cases you have 2. And that's how this works. And that is the end of 8.5 and 8.6. The 8.6 part is where it adds the objective function. The 8.5 part is everything else. So it's not so bad. It just takes a little bit. It takes a lot of steps here. It takes a little bit of work if you do it by hand. You could do it in the calculator and kind of show you all of this stuff, but I do it all by hand. So there you are.